Antarctica, a land of stark beauty, unforgiving cold. Beneath this frozen facade lies a secret, a hidden power that could reshape our world. Volcanoes, dormant but not extinct, slumber beneath the ice. These are not the fiery mountains of our imagination spewing lava into the sky. Antarctica's volcanoes are different. They hide beneath miles of ice, their presence betrayed by subtle clues, steam vents, deformed ice sheets, and seismic whispers. Scientists believe there are over 100 volcanoes buried within Antarctica found on the Earth's surface. The potential for destruction is immense, but so too is the opportunity for scientific discovery. Studying these volcanoes, understanding their behavior is crucial to understanding the future of our planet. Unveiling their secrets is not just a scientific endeavor, it's a matter of global importance. Volcanoes are windows into the Earth's fiery core, reminders of the immense forces that shape our planet. Antarctica, despite its icy exterior, is no stranger to these tectonic forces. The continent sits atop the Antarctic plate, surrounded by a ring of other plates. These plates are in constant motion, grinding against each other, creating zones of intense pressure and heat. It is in these zones, hidden beneath the ice, that Antarctica's volcanoes are born. Scientists rely on seismic imaging, radar mapping, and aerial surveys to piece together the secrets hidden beneath the ice. Evidence suggests that some of these volcanoes have erupted in the recent past, spewing ash and gas into the atmosphere. While these eruptions may not have been on the scale of a Krakatoa or Vesuvius, their impact on the fragile Antarctic environment could have been significant. The history of Antarctica is written in ice. Ice cores drilled from deep within the ice sheet provide a chronological record of past climate and atmospheric conditions. These cores reveal a startling fact. Antarctica's volcanoes have been active in the past, and their eruptions have left an indelible mark on the planet. One such eruption occurred around 2,000 years ago near the present-day Pine Island Glacier. Evidence suggests that this eruption was massive, spewing ash and gas high into the atmosphere. The eruption likely had a significant impact on the regional climate, potentially accelerating the melting of glaciers and contributing to rising sea levels. Another major eruption is believed to have occurred around 18,000 years ago, coinciding with the last glacial maximum. These ancient eruptions serve as a stark reminder of the potential power of Antarctica's volcanoes. Antarctica is home to a diverse range of volcanoes, each with its unique characteristics and potential threat level. Some are relatively small and isolated, while others are massive complexes that stretch for hundreds of miles beneath the ice. One of the most well-known Antarctic volcanoes is Mount Erebus, located on Ross Island. Erebus is one of the few volcanoes on Earth with a persistent lava lake, offering scientists a rare glimpse into the inner workings of an active volcano. While Erebus's eruptions are relatively small and pose no immediate threat to the continent, it serves as a reminder of the volcanic forces at play beneath the ice. Another notable volcano is Mount Sidley, the highest volcano in Antarctica. While there is no evidence of recent activity, its sheer size and potential for a large-scale eruption make it a volcano of significant concern. Perhaps the most concerning of Antarctica's volcanoes are those located beneath the West Antarctic ice sheet. An eruption beneath the West Antarctic ice sheet could have catastrophic consequences, accelerating ice melt and contributing to rapid sea level rise. The potential consequences of a major volcanic eruption in Antarctica are far-reaching and potentially devastating. While the immediate impact would be felt most acutely in the southern hemisphere, the effects would ripple outwards, impacting the entire planet. One of the most significant concerns is the impact on global sea levels. A volcanic eruption beneath these ice sheets could trigger rapid melting, sending billions of tons of water into the oceans. The influx of fresh water would disrupt ocean currents, impacting weather patterns and marine ecosystems worldwide. Coastal areas would be inundated, displacing millions of people and causing trillions of dollars in damage. Beyond sea level rise, volcanic eruptions release massive quantities of ash and gases into the atmosphere. These emissions can have a significant impact on global climate, blocking sunlight, altering atmospheric circulation patterns, and contributing to acid rain. The relationship between Antarctica's volcanoes and global sea levels is complex and intertwined. While volcanic eruptions can trigger rapid ice melt and contribute to sea level rise, they can also have the opposite effect, at least in the short term. Volcanic eruptions release large amounts of sulfur dioxide into the atmosphere. This gas, when combined with water vapor, forms sulfate aerosols, tiny particles that reflect sunlight back into space. This can have a cooling effect on the planet, potentially slowing down the rate of ice melt and sea level rise. However, this cooling effect is temporary. Once the sulfate aerosols settle out of the atmosphere, typically within a few years, the warming effects of greenhouse gases, such as carbon dioxide, take over. The net impact of volcanic eruptions on sea levels depends on a variety of factors, including the size and duration of the eruption, the composition of the erupted material, and the prevailing climate conditions. The interplay between volcanic eruptions and global warming is a complex and evolving area of scientific study. While volcanic eruptions can have both cooling and warming effects on the planet, their overall impact on the climate system is relatively small compared to human-caused greenhouse gas emissions. Volcanic eruptions release a cocktail of gases and particles into the atmosphere, some of which can influence the climate. Sulfur dioxide, as mentioned earlier, can have a cooling effect by reflecting sunlight back into space. However, volcanoes also release carbon dioxide, a potent greenhouse gas, which contributes to global warming. The amount of carbon dioxide released by even the largest volcanic eruptions is dwarfed by the amount released by human activities, such as burning fossil fuels and deforestation. While volcanic eruptions are not a significant driver of long-term climate change, they can still have a noticeable impact on regional and global temperatures in the short term. Monitoring the monster's scientific efforts in Antarctica. Given the potential global consequences of a major volcanic eruption in Antarctica, scientists are working tirelessly to monitor these sleeping giants and better understand their behavior. However, the extreme conditions and remoteness of the continent make this a challenging and expensive endeavor. Scientists rely on a range of techniques to monitor volcanic activity in Antarctica. Seismometers, deployed across the continent, detect the subtle tremors that often precede eruptions. GPS stations track ground deformation, which can indicate the movement of magma beneath the surface. And satellite imagery allows scientists to monitor changes in ice cover and gas emissions from volcanoes. While it may not be possible to prevent a volcanic eruption, early detection and timely warnings can help to mitigate the impact and save lives. Technological advancements, peering into the Earth. Recent advancements in technology are revolutionizing the way scientists study volcanoes in Antarctica. These technologies are allowing researchers to peer beneath the ice with unprecedented clarity, revealing the secrets of these hidden giants in greater detail than ever before. One such technology is airborne ice-penetrating radar. Mounted on aircraft, these radar systems emit pulses of energy that penetrate the ice sheet, bouncing back off the bedrock below. By analyzing the reflected signals, scientists can create detailed maps of the subglacial landscape, including the location and shape of volcanoes. Another promising technology is muon tomography. Muons are subatomic particles that are constantly bombarding the Earth from space. These particles can penetrate dense materials, such as rock and ice, allowing scientists to create images of the Earth's interior, similar to X-rays. International collaboration, a global effort for a global threat. The study and monitoring of Antarctica's volcanoes is a truly global effort, requiring collaboration and cooperation between scientists and institutions from around the world. No single nation has the resources or expertise to tackle this challenge alone. The Scientific Committee on Antarctic Research, SCAR, plays a crucial role in coordinating international research efforts in Antarctica. SCAR brings together scientists from different disciplines and countries to share knowledge, coordinate research projects, and develop strategies for addressing the challenges posed by climate change and other environmental threats. By working together, scientists can overcome the logistical and financial barriers to conducting research in Antarctica, and make more rapid progress in understanding these enigmatic volcanoes. International cooperation is not just desirable, it is essential for ensuring the safety and well-being of people and ecosystems around the world. Conclusion: our future, tied to a frozen continent. Antarctica, the frozen continent, may seem like a distant and desolate place, but its fate is inextricably linked to our own. The sleeping giants beneath its icy surface hold the potential to reshape our world, impacting sea levels, climate patterns, and the very air we breathe. Understanding these volcanoes, monitoring their behavior, and preparing for their potential awakening is not just a scientific endeavor, it is a matter of global importance. As we continue to explore and learn more about Antarctica's volcanoes, one thing is clear: our future is inextricably linked to the fate of this frozen